Welcome back to class. Let us continue with the topic of periodicity. In the first video, I have discussed about the periodicity of thermal and electrical conductivity. I told you that particular property is restricted to the metals on the periodic table because they are the conductors while the non-metals are non-conductors. I also discussed about the melting and boiling point as a property, how it varies across the period and down the group. And of course, I told you that there are three certain properties that have similar or same periodicity, and out of those three, I have discussed two. I have discussed ionization energy. I told you it is the energy that is required to remove an electron from the outermost shell of an element in its gaseous state. And then I went ahead to talk about electron affinity. I told you that electron affinity is simply the love of electron, okay, and it is the energy that is given off or lost when an element gains an electron. And so ionization energy, which is also called ionization potential, and electron affinity, I told you that both of them increase across the period and they decrease down the group. So what that means is that for group 7 elements, they have high ionization energy because the energy that you will use to remove an electron from the outermost shell here will be very high compared to the energy that will be required to remove an electron from the outermost shell at this point. So it's lower here and it's higher at this point. Now today we continue. We look at the third of those three that I spoke about. So I'll be talking about the next property, which is number 5, which is electronegativity. Electronegativity. It is the readiness of an element to become negatively charged by, so is it going to be by gaining electrons or by loss of electron? These guys are ready to gain electron. Givers are positive. So when you give out electron, you lose it, you become positively charged. While borrowing is negative. So they become negatively charged by borrowing electrons. So by accepting or borrowing electrons. So that is what you call electronegativity, and this property, it increases across the period and decrease down the group. So it increases across the period, it increases like this and decreases down the group. So that means electron affinity, ionization energy, and electronegativity is highest in group 7 elements. And because it's increasing like this and decreasing like this, which elements do you think we have the highest electronegativity? It is fluorine. And that is why fluorine is the most reactive element. No, on this table, fluorine is the most volatile and most reactive element. Alright, because it has the highest ionization energy. Right. So I have given an acronym for those three, and that is EIA. EIA. Same variation on the period or periodic table. A stands for electron affinity, I stands for ionization energy, E stands for electronegativity. So if they ask you which of the following increases across the period, or which of the following decreases across the period, and you have these three options and you have atomic radius or ionic radius, you can be sure that the answer will be ionic radius because the three of them, they have the same periodicity. Now for electropositivity, it is the readiness of an element to become positively charged by losing or donating electrons. So these guys, they have higher electropositivity because they are ready to lose electrons compared to these guys. All right, so they are ready to donate electrons. So electropositivity is highest here and lowest at this one. therefore it is decreasing across the period. So it decreases across the period and increases down the group. So when we talk about atomic radius, it increases down the group and decrease across the period. So that means as you are coming down this group, the atomic radius is increasing. Then for ionic radius, the same thing applies. Radius. I'm going to explain what that means to you. But for both of them, it increases down the group and it decreases across the period. Now, how do we define it? It's first important to note that the difference between atomic and ionic. Atomic is from the word atom, an atom and an aeon. The difference between them is that an atom is a neutral atom, is a neutral element. Okay, it has got no charge, no positive charge, no negative charge, while aeons are carrying charges. So aeons could be positive or negative. So when an element has lost electron or gained electron, it becomes an aeon. So it's now carrying a charge. So for example, when sodium loses an electron, becomes Na plus. So from Na and Na plus, this is an atom and this is an aeon. So this is an aeon because it's positively charged, it has lost electron. Chlorine is an aeon. Wow, that's chlorine aeon. Alright? And this positive aeon is what you call cation. Alright? It's called a cation, and this is called the anion. Anions are negatively charged. So that's the difference between atom and aeon. When an element has lost or gained electron, it becomes an aeon. Is that okay? Now, let me now talk about the radius aspect of it, which I told you it's exactly the same. Members of the same period, they have the same number of electron shells, while numbers in the same group, they have number of electrons in their outermost shell. So this group 3, they have 3 in the outermost shell. This is period 3, they all have 3 shells. This 1 2 3 1 2 3 1 2 3, all of them are in the same shells. So period 1, they have just 1 shell. This is period 2, 2 shells. Period 3, 3 shells. And then period 4, 4 shells. Now in mathematics, when we say radius, what is radius in mathematics? In your mathematics, radius is just half of the diameter of a circle. So if the distance from the center of a circle to any part of the circumference, this is a circumference, that is what you call radius. From the center of a circle to any part of the circumference, that is the radius. Alright, so if I have an element that has just 1 shell, look at the radius of this element, this, and then I have another element in period 4 that has 4 shells, 1 2 3 4, and I ask you which of them will have a longer radius. So here, from here to here, radius compared to this, you will see that the one that has 4 shells has a bigger radius. What does that mean to you? As you come down the group, the shells increases, 1 shell, 2 3. As it comes down here, this is 1 shell, 2 shells, 3 shells, 4 shells. So as you come down, the radius increases. That is why we said the atomic radius increases down the group and it decreases across the period, and the same thing applies to ionic radius. So your atomic radius and your ionic radius, they have the same periodicity on the table. Is that okay? So you can as well say your EAI, which is your ionization energy, your electron affinity and electronegativity, they have the same periodicity, meaning they increase across the period and decrease down the group. Then these 3 properties too, your atomic radius, your ionic radius, atomic radius, and your electropositivity, RP. Let's use RP. That means all the radius and the positivity, electropositivity, they also have similar periodicity. And what is that similar periodicity? They increase down the group and they decrease across the period. I want to believe that you now understand the periodic properties and their periodicity of the periodic table. If you have not seen the first video, check at the comment section or the description to this video, you will see the link to the first video. Do well to watch so you can have a comprehensive understanding of this topic. And if you've got value from this topic, go to the comment section and type in value. Let others know that you got value, and please share this video. If you have not subscribed to our channel, do well to subscribe to our channel. My name is Coach Paul. I look forward to seeing you in the next class. Bye for now.